Okay, here we go. Geometry students, on the back of your notes today, what is a diagonal of a polygon? Well, we've talked about this a bit. A diagonal is a line segment that connects two non-consecutive vertices. Remember, the word non-consecutive here, or the term non-consecutive, that means that they can't be next to each other. So in a square here, this and this, those are consecutive vertices. This and this, those are non-consecutive vertices. So in order to be a diagonal, it has to be a line segment connecting non-consecutive vertices. What do we know about the interior angles of all quadrilaterals? All four-sided figures, they have a sum of 360 degrees. So if you take the interior angles of any four-sided figure, add up those angle measures, it'll be 360. All right, now we're going to talk about the parts of special polygons. We'll start with a trapezoid. By definition, remember, the trapezoid is a shape that has two uh, parallel lines. So those parallel lines are pretty much the only thing about a trapezoid that makes it special. And so we don't really have anything to say about the diagonals. Let's draw those diagonals in there. Those diagonals, so they don't cross anywhere important like making these two congruent or anything like that. They don't cross at a 90-degree angle. So we'll say not applicable. There's just nothing kind of special about those. And the angles, so the angles here, those are not 90 degrees, or the diagonals don't do anything special with them. The consecutive angles don't have anything special. And the sides, other than having one pair of parallel sides, there's just nothing special about those either. So trapezoids, not a lot going on that makes them kind of have special characteristics other than one pair of parallel sides. With a kite, remember, we have these two consecutive congruent pairs of sides. So these are two consecutive pairs of congruent sides. And when we have two congruent pairs of consecutive sides, some special things do actually happen. So here we have our our diagonal and another diagonal. And it's important that one of these diagonals, this one in this case, is bisected. So one is bisected. And it's pretty obvious to see that this other diagonal is not bisected. This is not congruent to that. In our angles, from the vertex where the one that is bisected to the other vertex where it's bisected, the diagonal, um, those angles have to be congruent. So that's another thing that happens. So we have one pair is congruent of the angles in a kite. And in A kite, we have two pairs of congruent sides, but other than that, there's nothing happening that is special about the kite. So the definition tells us that the sides are two pairs of sides are congruent, but nothing, outside of that, there's nothing happening. Parallelogram, let's draw in those diagonals. That one didn't go to where I wanted it to. There we go. There we go. All right. In a parallelogram, as we saw in a kite, one of the diagonals was bisected. Well, in a parallelogram, both are bisected. So that's a pretty big deal. And we also have in the angles, opposite angles are congruent. And lastly, on our sides, opposite sides have to be congruent. So that's all important with a parallelogram. Rhombus, drawing those diagonals. Now remember, with a rhombus, by definition, it is a parallelogram with four congruent sides. So with a rhombus, all of the properties of parallelograms hold for a rhombus. So I'm going to write all properties of parallelogram. In addition to that, with our diagonals, they intersect at a right angle, so they're perpendicular to each other. So all diagonals are perpendicular in a rhombus. In the angles, all angles are bisected by the diagonals. So the angles are bisected by diagonals. And I just thought, oh, I wonder if anyone out there has forgotten what the word bisected means. Bisected means cut in half. So that's what we're talking about there. The sides, well, by definition, all sides are congruent. By definition, the opposite sides are parallel. Other than that, I mean, that's all pretty big. So other than that, there's nothing extra that we need to say about rhombus. Rectangles. Again, we have a situation where, by definition, a rectangle is a parallelogram. So again, I'm going to say all properties of parallelograms. The diagonals, when we draw those in, uh, with a parallelogram, the diagonals are bisected. So because this is a parallelogram, the diagonals have to be bisected. And other than that, there is nothing happening there. Whoops. The angles in a rectangle, remember that in a quadrilateral, all four angles have to add to 360 degrees. And in a rectangle, the definition says that the four angles are congruent. The only way for that to happen is that all the angles are right angles. And the sides, by definition, the opposite sides are parallel, but additionally, a feature is that opposite sides are congruent. And that's the rectangle. With a square, the diagonals, we put them in there, they are bisected. And in fact, the diagonals are, oh, I guess I should have added one thing over here. I'm sorry. The diagonals are congruent. That is one thing. That's true. The diagonals are congruent and they're bisected in congruent ways too. So similar over here, the diagonals are congruent and they're bisected. The angles are right angles and the sides are congruent. And that is the square. So make sure you do that daily work. Hope this all helps and be ready for that quiz next week.